Welcome back to Weld Fab World. This is Lecture 2 of our 18-part series on ASME Section IX. In Lecture 1 we covered the foundational paragraphs of Part QG, QG 100 through QG 106. We covered scope, procedure specifications, the PQR, record keeping, variable classification, and organizational responsibility. In this lecture we complete Part QG. We are finishing with QG 107, QG 108, and QG 109, and when this lecture is done, you will have covered every single paragraph in the General Requirements section of the code. The topics for today may look shorter, but do not underestimate them. The definition section alone, QG 109, is what most engineers skip when they first read the code, and it is exactly what trips them up later. When an authorized inspector challenges your qualification record or a dispute arises about a weld procedure, the argument almost always comes back to what a specific word means under Section X. And Section 9 has its own dictionary. We are going to build that dictionary today. Let's get started. Let me orient you to today's agenda. On the left side of the slide is a quick recap of what we covered in Lecture 1, QG 100 through QG 106. We are not revisiting those in detail, but you will see them referenced throughout today's lecture because everything connects. On the right side is what we are covering today. QG 107, ISO Cross-Qualification. When can a welder qualified under ISO NUN 606-1 or ISO 14732 be accepted under ASME Section 9? And what does the manufacturer have to do to make that happen? QG 108, Previous Edition Qualifications. Section 9 is revised every 2 years on the ASME cycle. What happens to your existing WPS and PQR documents when a new edition comes out? Do you have to requalify? The short answer is no, but there are conditions. QG 109, Retesting Rules. What happens when a qualification test fails? There is a structured pathway in the code, and we are going to walk through it step by step. Then we spend the most time today on QG 109 definitions. Section 9 uses precise, purpose-built terminology. When the code says manufacturer, it means something specific. When it says groove weld, heat input, or base metal, it means exactly what QG 109 defines, not the dictionary definition, not what your supervisor calls it on the shop floor. Knowing these definitions is what separates someone who uses the code from someone who understands it. We finish with a complete definitions cheat sheet, a reference slide you can screenshot and keep. Let's talk about ISO cross-qualification. This is a topic that comes up constantly in global fabrication shops, especially when you have welders who were trained and qualified in Europe or elsewhere under ISO standards, and you need them to work on ASME stamped pressure equipment. The question is, can you accept an ISO qualification for ASME Section 9 work without making the welder requalify from scratch? The answer is yes, under specific conditions, and it is addressed in non-mandatory Appendix L of Section 9, which deals with welders and welding operators qualified simultaneously to ISO 9606-1, ISO 14372, and Section 9. Let me explain the two ISO standards involved. ISO 9606-1 2012 is the qualification standard for welders performing fusion welding of steels, including carbon steel, alloy steel, and stainless steel. It covers manual and semi-automatic welders. This is the European equivalent of the welder performance qualification that Section 9 addresses through Part QW. ISO 14732-2013 is the qualification standard for welding operators, specifically those operating mechanized or automated welding equipment. Think submerged arc welding operators, robotic welding cell operators, and so on. Here is the mechanism. ASME Section 9 Appendix L recognizes that recent revisions to ISO TC44 have brought ISO 9606-1 and ISO 14732 much closer in structure to Section 9 requirements. The code states that when a test coupon has been mechanically tested according to ISO 9606-1 or ISO 14732 and found acceptable, those same test results also satisfy the requirements of Section 9. provided the administrative and technical conditions in Appendix L are met. What are those conditions? First, the welding of the test coupon must have been done under the full supervision and control of the qualifying organization. Supervision cannot be delegated. This is the same QG 106 responsibility principle we covered in Lecture 1. Second, the essential variables for the welding process must be recorded on the qualification record, and the ranges qualified must be listed. The code is clear that while the actual values on the record may look the same between an ISO and ASME record, the ranges qualified will be different, because Section 9 computes them differently from ISO 9601-1. Third, the test coupon material must be drawn from base metals assigned a P number under QW 420, and filler metals must be assigned F numbers per table QW 432. This ensures full interchangeability with ASME materials classifications. Fourth, for NDE performed on the test coupon, specific rules apply. Radiographic examination must satisfy QW 191.1. Ultrasonic examination must satisfy QW 191.2. And here is an important exception. Test coupons tested by fracture test per ISO 9017 do not satisfy Section 9 requirements. That test method is simply not accepted by the code. The slide notes one important limitation for ISO 14372 documentation. All records must be available for review, and if they are not in English, a certified translation is required. The manufacturer making the acceptance decision takes full responsibility under QG 106. And that brings us to the key condition at the bottom of the slide, and this is the one I want you to remember above everything else on this slide. The manufacturer who accepts an ISO qualification is still fully responsible under QG 106. They must review the records, verify that every essential variable falls within the ASME qualified ranges, and formally document their acceptance decision. A welder does not automatically become ASME qualified because they hold an ISO certificate. The manufacturer makes that determination and takes legal responsibility for it. QG 108. This paragraph was revised in its entirety in the 2025 edition, so pay attention to this even if you think you already know it. Section 9 operates on a 2-year revision cycle. A new edition comes out, and immediately the question arises in fabrication shops everywhere. Do we have to requalify all our existing WPS and PQR documents? The code's answer, and this is a foundational protection for manufacturers, is no. QG 108A states clearly that procedure specifications, procedure qualifications, and performance qualifications made in accordance with earlier editions of Section 9 may be used for any construction for which the current edition has been specified. Such procedures and qualifications do not require amendment to include changes required by later editions. Let me say that again more plainly. If your company qualified a welding procedure in 1998 under the 1998 edition of Section 9, that qualification is still valid today in 2025. You do not need to retest. You do not need to revise the WPS to add language from 2007 or 2013 or 2023. The ASME code respects existing qualifications. This is a commercially important rule. The cost of requalifying every historical WPS at each new edition would be enormous for any large fabricator. However, there is an important exception you must understand. New qualifications, those performed after a new edition comes into force, must comply with the current edition at the time they are performed. So if you are qualifying a brand new WPS today, in 2025, that qualification must meet the 2025 edition requirements. The slide example makes this concrete. If you qualified a WPS under the 2017 edition and it is still valid, you continue using it as is. But if you are now writing and qualifying a new WPS in 2025, that new qualification must be done to the 2025 edition, not to the 2017 edition you might be more familiar with. QG 108b adds an important sub-rule. Existing PQRs may be used to support new or revised procedure specifications written to a later edition, but only if the essential variables and supplementary essential variables identified in that later addition were already documented in those existing PQR records. If a new addition adds a new essential variable that was never recorded on your old PQR, you cannot use that old PQR to support a new WPS until the new variable requirement is satisfied. And QG 108(c) is clear. New procedure and performance qualifications shall be in accordance with the current edition. No choosing an older edition because it is more convenient. The practical advice on the slide is something I strongly recommend. When auditors or authorized inspectors review your qualification records, they will check which edition was current at the time the qualification was performed. Always, and I mean always, record the edition of Section 9 on your PQR and WPQ at the time of qualification. If you cannot demonstrate which edition applied at the time of testing, the qualification may be challenged. It is a simple thing to write down and it protects you completely. Now we come to retesting. What happens when a qualification test fails? This applies to both procedure qualification testing and performance qualification testing, though in practice, performance qualification failures, welder tests, are more common. Let's walk through the structured pathway the code provides. The diagram on the slide shows the two options. Option 1, the immediate retest path. Step 1, the test fails. One or more specimens do not meet the acceptance criteria. For a bend test, that might mean a crack longer than 3 mm has opened on the surface. For a tension test, it might mean the specimen fractured in the weld metal below the minimum tensile strength of the base metal specification. Step 2. The welder or organization may immediately, without any additional training or practice, weld 2 additional test coupons using identical variables to the failed test. The code requires 2, not 1. Step 3. Both additional specimens must pass. Not one of 2. Both. If only one passes, the qualification is not granted. The failure stands. Step 4. If both pass, the original failure is disregarded and the full qualification range is granted. This is an important detail worth repeating. The immediate retest requires 2 coupons, and both must pass. This is stricter than some people remember. A single successful retest is not sufficient. Option 2, practice before retesting. A welder or welding operator may undergo additional training or practice before attempting another test. The code does not specify a minimum practice period. The manufacturer must be satisfied that the deficiency identified in the failure has been addressed. Best practice, and most quality systems require this, is to document the additional practice, noting what was done and for how long, before the retest is attempted. There is also a mandatory retest provision that goes beyond the standard failure and retest scenario. Even if a welder is within their continuity period, which under QW 322 is 6 months of continuous use of a welding process, the manufacturer or the authorized inspector may require a retest if there is a specific reason to question the welder's ability to produce sound welds. What constitutes a specific reason? The slide gives you 3 examples that come up in practice. An NDE detected defect pattern in production welds. Say, a recurring cluster of porosity or lack of fusion in that welder's work. An unusual number of visual rejections from the same individual, or direct observation during welding that raises concerns about technique or consistency. This is a judgment call. The responsible supervisor makes it, and their decision must be documented. It is not a punitive provision, it is a quality protection tool. Now we move into definitions. I am going to take some time on these because they matter. Backing. The code definition. A material placed at the root of a weld joint for the purpose of supporting molten weld metal. The material may or may not fuse into the joint. This is important because backing type, whether you use steel backing, ceramic backing, flux backing, backing gas, or weld metal backing, is tracked as a variable in the procedure. A change in backing type can be an essential variable depending on the process. The code also distinguishes between backing and retainer. A retainer is a non-consumable material used to contain or shape the weld metal but is not a backing in the code's sense. Base metal. The metal to be welded. In Section IX, base metals are classified by P number under QW 420. The code requires that base metals either be listed in Table QW, QB 422 or have a P number assigned by the manufacturer. The P number system groups materials with similar weldability, allowing qualifications to cover multiple materials within a group. Bead, a single run of weld metal deposited in one pass. Multiple beads form layers. Multiple layers build up the cross-section. This definition is the basis for the distinction between a layer and a pass, words that are used precisely in Section IX procedure documentation. Buttering. The code defines this as the addition of material by welding on one or both faces of a joint prior to the preparation of the joint for final welding, for the purpose of providing a suitable transition weld deposit for subsequent welding. Buttering is used when you are joining dissimilar metals and need to put a compatible intermediate layer on the face of one member before making the final joint weld. Buttering has its own qualification considerations and is tracked as a variable. Contractor, the organization responsible for welding on a specific job. This could be the owner, the primary fabricator, or a subcontractor. The key point from QG 109 and QG 106 together. Whoever is acting as the contractor bears the QG 106 responsibility for qualification. In a subcontract arrangement, the subcontractor doing the pressure boundary welding is the contractor, for qualification purposes, not the prime contractor who hired them. Deposited weld metal, filler metal that has been added during welding and has become part of the finished weld. Distinct from the base metal even if the two happen to be the same alloy. This distinction matters in chemistry calculations and a number classification. Filler metal, metal or alloy added to the weld pool during welding. Classified in Section IX by two systems. F number which groups filler metals by usability characteristics, and a number which groups them by deposited weld metal chemistry. Filler metal may be an electrode, a rod, a wire, or a pre-placed insert. Fusion, the melting and joining together of base metal and filler metal. The term fusion line means the boundary between the weld metal and the heat-affected zone. Incomplete fusion is a weld defect. It means the weld metal and base metal or adjacent layers were not fully melted and joined together. Groove weld, the code definition. A weld made in a groove formed within a single member or in the groove between two members to be joined. Groove types include square, single V, double V, single U, double U, single bevel, double bevel, single J, double J, and several flare variations. Groove welds carry the primary structural and pressure load in most pressure vessel applications. Heat input. This is a calculated value, not a measured one. The formula is heat input in kilojoules per millimeter equals amps multiplied by volts multiplied by 60. Divided by the product of 1000 and travel speed in millimeters per minute. Written out, kilojoule per millimeter equals I times V times 60, 1000 times S. Why does this matter? High heat input means a slower cooling rate through the critical temperature range, which leads to coarser grain structure and lower toughness in the has and weld metal. Low heat input means faster cooling, which can lead to harder, more crack-susceptible microstructures, particularly in higher-strength steels. Heat input is a supplementary essential variable for toughness-sensitive procedures. Heat-affected zone, the has. The code's definition, that portion of the base metal which has not been melted, but whose mechanical properties or microstructures have been altered by the heat of welding or cutting. The has is not weld metal, it was never liquid. But it was heated to temperatures where phase transformations and grain growth occurred. It is often the most critical zone for toughness and hardness performance, which is why preheat, interpass temperature, and PWHT all target the has properties. Interpass temperature. The code defines this as the temperature of the previously deposited weld metal or adjacent base metal, typically within 25 mm of the weld deposit, immediately before the next pass is started. Maximum interpass temperature is a supplementary essential variable when toughness testing is required. The reason, if interpass temperature is allowed to rise too high between passes, the equivalent of a PWHT is applied to earlier passes, and the cumulative heat effect can degrade toughness in ways not captured by a test coupon that was welded with a controlled interpass. Layer. One or more beads deposited at approximately the same level in the cross-section of a weld. A multi-pass weld consists of multiple layers. The distinction between a layer and a pass is worth knowing. One pass deposits one bead. Multiple beads side by side at the same cross-sectional level form a layer. Section IX's figures QG 109.2.1 and QG 109.2.2 show this visually. A great reference if you have not looked at them. Manufacturer. Here is a definition that confuses people in subcontract arrangements. The code's QG 109.2 definition for organization covers it: a manufacturer, contractor, assembler, installer, or other entity having responsibility for operational control of the material joining methods used in the construction of components. For qualification purposes, the manufacturer is the entity that bears primary QG 106 responsibility, the one that runs the qualification tests, certifies the PQR, and is responsible for the supervision and control of production welding. In a subcontract arrangement, if a subcontractor is welding the pressure boundary under an ASME stamp, that subcontractor is the manufacturer for qualification purposes, even though a larger prime contractor may hold the overall contract. Pass. A single progression of welding along the joint. One pass equals one bead. A weld may consist of a single pass or many passes. A heavy wall pressure vessel nozzle joint might require 30 or 40 passes. Each pass is documented on the WPS and PQR in terms of travel speed, current, voltage, and bead sequence. Peening. Mechanical working of welds and base metal by impact, hammering. The code tracks use or omission of peening as a supplementary essential variable when toughness testing is required. Peening can induce compressive residual stresses that affect toughness test results, so a procedure qualified with peening cannot simply omit it in production without re-evaluation. Position. The orientation of the weld axis and weld face during welding. The standard positions are: flat, 1G or 1F, horizontal, 2G or 2F, vertical, 3G or 3F, overhead, 4G or 4F, fixed pipe horizontal, 5G, pipe inclined at 45 degrees, 6G, and restricted access pipe inclined at 45 degrees, 6GR. We will cover weld positions in much more depth in Lecture 3 when we go into Article 1 Post-Weld Heat Treatment, PWHT. Controlled heating of the completed weld and adjacent base metal above a specified temperature, followed by controlled cooling. PWHT serves several metallurgical purposes. It relieves residual welding stresses, tempers any martensite formed in the HAZ during rapid cooling, improves toughness, and reduces susceptibility to stress corrosion cracking. Addition or deletion of PWHT is an essential variable, meaning any change requires a new PQR. A change in PWHT temperature range is also an essential variable. Preheat. Heat applied to the base metal before and during welding, measured in the weld joint preparation immediately prior to welding, or in the case of multi-pass welds, in the previously deposited weld metal immediately prior to each pass. The minimum preheat temperature is typically an essential variable. The purpose is to slow the cooling rate, reduce HAZ hardness, prevent hydrogen-induced cracking, and reduce thermal shock in thick sections. Procedure Qualification Record, PQR. We covered this in depth in Lecture 1, but its definition is here in QG 109, the written record of the actual welding variables and test results used to qualify a WPS. It is the legally binding evidence document. It cannot be altered after certification. Technique. The method of welding, including stringer bead versus weave bead, oscillation pattern, single versus multiple electrodes, string of beads versus weave approach. The code says in the specific variable tables that technique changes are typically non-essential variables, meaning they can be changed by WPS revision without a new PQR.